So in this problem, we're not given the function. We're going to need to actually find the function. It's exponential growth. So they're saying that after 2 hours, there's 800 bacteria. And after 10 hours, there's 80,000. Exponential growth means that it would grow faster and faster, like this. And then it's got a constant relative growth rate. This says if you take the speed at which the population is changing divided by the size of the population, then it's always going to be a constant growth rate. This then is a differential equation. In other words, it's an equation that has a derivative in it, and we need to find the original equation or expression. Well, since this is the derivative of something divided by that something, that's actually coming from the natural log of that something. So if y were equal to the natural log of p, then take the derivative of it, and first of all the derivative of natural log would give us 1 over p, and then the chain rule would say take the derivative of the inside. That would be p prime. So this process is asking us to go backwards from that. So you've got p prime over p, go backwards, and the original function would have been natural log. So this side over here would be the natural log of p, and this side, since it's a constant, that means that somebody took the derivative and it was a constant times the variable. And in here, the variable is t instead of what we usually use, x. So, in other words, if it was y equals 7t, and you're taking the derivative with respect to t, you get just the constant 7. So, in this process, we're going backwards, so go backwards from that constant, and it's the constant times t. And now we can either substitute in the numbers right now, the time and the p, or we could go ahead and eliminate natural log by exponentiating both sides. I got so caught up in my side work over here, I forgot to say plus. There could have been a constant, because the derivative of a constant is 0. So it's possible that there was a constant there. So you take the derivative of a constant times t, gives you just the constant. If there's a constant just by itself, the derivative is 0. Okay, now the next thing that I'm going to do is exponentiate both sides so that we're no longer working with natural log. So we've got the function p equals e to the kt plus c. One other thing I'm going to do is, there's a rule in algebra that says if you have a to the n times a to the m, then you can rewrite it as a single base a to the n plus m. Except instead of using it from left to right, I'm going to use it this way. So I've got e raised to some two things added together. I'm going to break that into e to those two things individually. So we've got p equals e to the c and e to the kt. Great. Now all we have to do is find out what is c and what is k by plugging in actual numbers. So there were 800 bacteria after 2 hours, so that's the time. And there were 80,000 bacteria, and that was after 10 hours. And now I've got two equations with two variables. Well, I noticed that they both have e to the c. So if I were to divide the two, that would eliminate e to the c. So if I took 80,000 divided by 800 for the left sides, then take e to the c and e to the 10k and divide it by e to the c and e to the 2k, we would get 100 equals e to the 8k. So then just take natural log of both sides. Natural log of 100, and then divide that by 8, and there we have the k. K is equal to 0.576. So that's the growth rate of the bacteria, 57.6% growth rate, pretty fast. Then go back to one of these equations, like this one right here, substitute that information in. And so it's now beginning to look like the Pert formula. Excuse me. So go back to, I've got the K, I need the 2. Okay, so to solve for e to the c, just divide by this thing. So we've got e to the c is equal to an 800 divided by e to the 0.576 times 2. So an 800 divided by e to the 0.576 times 2. And so we've got that e to the c is equal to 252.803. And then we're finished. Because this right here is essentially the Pert formula. We've got the k, which is the growth rate, and what's supposed to go in front of that is what were the starting number of bacteria. And we've got that right there, e to the c. We don't have to solve for c, we just need to know what goes in front. So it's going to be p equals, start with 252.803 bacteria, and then it's going to grow exponentially at a rate of 57.6% over time. So find an expression after t hours. There we go.